All right, welcome to function operations. So this is a little bit of a different style than we're used to. Just to give you a quick tour, the handout is 3 pages long, and you don't have to do as much writing because you just kind of have to fill in the blank and answer the questions. You'll notice on the left-hand side it says write your questions here. So this is kind of Cornell's notes style. So these are questions that you should be writing that ask sort of questions of the answers that are in here. So in the beginning here it says to combine two functions, f of x and g of x, add or subtract as follows. So your question, you might want to, I'll write the question the first time, but I'm expecting you guys to do this. Might be how do you find, like how to find sum of functions. For example, it might be a question. And here would be the answer, is you can, and I'll show you how the notation works over here. So this is how you do a sum of functions, and here you do a difference of functions. So you can do a series of questions along the way. You can either do it while you're taking the notes or afterwards. And at the very end, there's a place where you can write a quick summary. So again, I think this is something that will help you remember and take notes and learn and things like that. So if we have two functions, f of x and g of x, we can add them together. So in this case, we're creating a new function called h of x. So h of x is the sum of f of x and g of x. Really what you end up doing is for a sum of functions, you're adding the y values and you're keeping the x values the same. So in the short form is add the y values. And here's what it looks like. So we're going to do question 1, which is given the functions. So here are the two functions, f of x and g of x. Find f plus g of x and f minus g of x. Now, if I just go back over here, these are two different ways of saying the same thing. Sometimes the textbook and the provincial exam does this, f plus g of x, more often, but this means exactly the same thing. So I've opted for that second style of writing it together. So how do you do this? Well, you just really add them together. So I'm going to say that this is going to be so h of x, I'll call our new function h of x. It's going to be equal to this one plus this one. So this first time, I'll write it all out, f plus g of x. So that's going to be equal to 2x minus 7 plus, I'll put parentheses around here, x plus 3. So we just put those together, and what does that add up to? I'll squish it in here. 2x plus x is 3x minus 4. Okay, so there's my answer for the f plus g of x. Now if I'm going to do f minus g of x, that's going to be equal to 2x minus 7, subtract left parentheses x plus 3. And now you'll notice, of course, when I take away the brackets, 2x minus 7 minus x minus 3. So just be careful with those brackets. 2x minus x is x, minus 7 and minus 3 is minus 10. Okay, so here's our answer for the f minus g of x. So what do? You just subtract. It's pretty straightforward. Now here's a question. What is f plus g of 3? So in other words, if I plug a 3 into our new function here, f plus g, what do I get as an answer? So the easiest way to do this is to take this. If I'll write it out sort of a long way first of all. If f plus g of x is equal to 3x minus 4, that's what we found in our previous question, then, and I'll erase this in a second, but that means that f plus g of 3 is going to be equal to 3 times 3 minus 4. So this is why we do this style of notation. Whatever goes in here, an x shows up there. So if we plug a 3 in, this is what comes out. 3 times 3 is 9, minus 4 is equal to 5. So our answer is 5 on that one. F minus g at 1. So really, just put a 1 here, because we already figured it out. So we get 1 minus 10, which is equal to 9. I'll just show you there is another way of doing that. We'll switch to green here. This f minus g at 1, if I use this kind of notation, it kind of makes sense here. This would be the same thing as f of 1 minus g of 1. Right? So I could go back to my original definitions of f of x and put a 1 here. 2 times 1 is 2, minus 7 is minus 5. Minus, now if I put a 1 here, 1 plus 3 is 4. Oh, did I make a mistake here? 1, I got a 9, and here I'm getting a minus 9. Oh, that's why, because I forgot about a minus over there. Hey, it's a good check. So you see there's two different ways of doing it. If you'd already algebraically found the difference of the difference function here, f minus g, if you'd already found this statement over here, you know, why not make use of it and just plug your number in there? Of course, mind your integers. 1 minus 10 is minus 9. Or if not, you can do them this way. Okay, let's see how my eraser is going to work on this. It's a little delayed, but it seems to work. Okay, so let's do the same thing here. So x squared plus 1 and x squared plus 2x minus 1. So my f plus g, my sum of the functions of x is going to be equal to, I'm going to just add the two together, 2x squared plus 2x, and then the plus 1 and the minus 1 cancel each other out, don't they? I'll switch to green for the difference here, so f minus g at x. I've got to be a little bit careful, so I'll write it out here. I'll write x squared plus 1 minus left parentheses x squared plus 2x minus 1. So what my x squareds cancel each other out, I'm going to get a minus 2x plus 1 plus 2. And so there is my answer. Okay. Let's scroll down here. And again, similar style question here. What happens if we plug a 3 in there? So I'll put my answer up here. F plus g of 3 will be equal to 2 times 3 squared plus 2 times 3. So that's going to be equal to what? 2 times 9 is 18 plus 6. So that's going to be equal to 24. So this answer here is 24. F minus g at 1, if I put a 1 here, negative 2 times 1 is negative 2 plus 2 is 0. Oh, neat, it cancels each other out. Okay, so that's the first part of the lesson. Hopefully that was fairly straightforward. Here are the graphs of functions. Find out f plus g at 0 and f minus g at 1, things like that. So you know what, why don't we call this one f, and I'm going to zoom in just a little bit more so we can see things better here. Try to zoom in a bit more. There we go. We'll call that one f, and then green will be our g function here. Okay. Now find f plus g at 0. So just a reminder then, that really means that we want to find out what is f at 0, right, plus what is g at 0. So I plug in an x value of 0 and I find out what my y value is. So here, right, because this is x, when x is 0, what is the y value? So f at 0 is equal to 1, 2, 3. So this is equal to 3. Plus g at 0, down here, g at 0 is equal to what? 1, 2, 3, 4. This is where negative 5 is. A little bit hard to tell. So it's negative 7, isn't it? Plus negative 7. So that will be equal to negative 4. Let me switch to green for my subtraction one. So this is going to be the same thing as f of 1 minus g at 1. So at 1, so here's 1. It seems to me f at 1 is going to be equal to 1, 2, 3, 4. So that's 4. Minus g at 1, which looks like negative 1, 2. Oh, you know what? I made a mistake because here is where 1 is, right? 1. No, I did it right. 1, 2, 3, 4, 5. I thought the scale was different. No, we're good. G at 1 is negative 1, 2, 3, 4, 5 at negative 5. So subtract negative 5 like that. So we get 9. All right. Now it says graph f plus g at x. Well, right now it's a little bit hard to figure these things out here. I think it would be best to make a table of values. So let's put what x is, and then we'll put what f of x is, figure out what g of x is, and then f plus g of x. Okay, so we'll put in a few values here. And we have one already. We have this one here, 0. So, you know what, I'll do a... Does -1 seem to work out all right? Oh, this one doesn't go as far. So 0 will be our first one. So 0, we found that f at 0 was 3. G at 0 was -7. F plus g of x is equal to -4. So I'll do a little bit of erasing here just to give us a bit of... I'll try to do some erasing. Oh, there we go. Okay, so if we put in our dots here, so at 0, we get f plus g at -4. So -1, 2, 3, 4. So this up plus this downwards negative gives me a -4. So that's my first place on the dot. Okay, how about we put at 2 now? So f... Oh, you know what? Did I mix up my f and my g? I think I did. F at 0, I said this was f, so it comes down over here. So I mixed up my numbers here. So the 3, this should have been a -7, and that should have been a 3. So that gives me a -4. So I think maybe this number might have got mixed up. F at 1 and minus g at 1. Let's make a little change here. Sorry guys, it seems to me... Oh, you know what? I'll make the change over top of it like this. F at 1 was the negative version. So really this should have been... So this is wrong, x. So it should be -5 subtract 4 equals -9. So careful about watching which one is the f and which one is the g, right? So f comes down this way. So this is f. And then this is g, so the order was a little bit different. And over here, I should even make this change here. At 0, f of x is the -7, and g of x is the 3. But thankfully, that -4 stays the same. Okay, so let's carry on. At 2, so at this part over here, at 2, f of x is equal to... Whoa, f of x down here is equal to -1, 2, 3. G of x is equal to 1, 2, 3, 4, 5. So we get a 2. And we'll do, how about at 4? So at 4 is at the spot here. F of x is equal to 1. G of x looks like it's equal to 2, 3, 4, 5, 6, 7. So we get an answer of 8. Okay, so now we'll put these points in. Here, I'll pick a nice thick red one here. So at 0, we get that -4 I put in before. At x is 2, f plus g of x is also 2. So we get one right there. At 4, we get 8. So 4, we get 5, 6, 7, 8. And that's where we get that nice line. Let me see here. If I go and try, if we go to insert, let me try this here. Hopefully everything will work. I want a nice line. No, come on. Insert a shape, a line. Okay, Word, do me proud. Okay, so here we go. It's not a great line, it's kind of a faint blue one, but that's how it looks like afterwards. You get to use your ruler rather than fussing with this software like this, but that's what we get. Okay, let's scroll away a little bit. And not too surprising, when we add two lines together, we get another straight line. Here is another example of f plus g. We have two parabolas here when we add them together. You know what? Let's figure out some of this. You know, I'm going to just to speed things up, I'm going to skip this one here and let's go to our next one, the absolute value one. And it's this exact same process that we did a second ago. And if we're going to do this in class later on, I think what I would do is call this one F. So it's that one, and F comes out over here. And then this one would be G, and G comes out over here. But we'll see. Well, if you guys ask me, we can do that in class. But just to keep this video a little bit shorter, just because there's so much looking up x and y, let's try this function here. It says f is a function, and then g is the absolute value. So this one is f, and this one is g. And we're going to find f plus g of x. So it's the same process we did. We're going to say x, and then we'll find f of x. And then we'll find g of x, and then f plus g at x. And we can anticipate the behavior is going to change at 0. Like here it's like adding two straight lines. Like this is a straight line, the g function, and this is a straight line f function. So I think we're going to get another straight line here, but then g of x changes its behavior at this point. Like it doesn't continue to go that way. So why don't we pick a few points? Why don't we go -2, -1, and then 0. And then that 3 points will be enough to find some type of behavior. And then we'll switch over, and then we'll say 1, 2, and then 3. Okay, so we'll do quite a few points. We'll do 5 points altogether. Okay, so again, I'll just label both sides so I don't make that mistake again. When x is -2, this looks like it is positive 1, 2, 3. 1, 2, 3. F of x is 3 and g of x is 3 at the same spot, so f plus g of x is 6. So I can even put that in right now. So 3, 4, 5, 6 when I add them together, right? And you can think of this plus this gives you that, so you add them two together. At -1, f of x is equal to 6 and g of x is equal to 2, so we get 8. And again, you can think, okay, at -1, I'm going, okay, this is 2, right? This is 6. So if I was to, hey, maybe I can do something fancy here. If I was to take this one and put it at the end of that one, does that kind of work? Oh, there we go. So the 2 added together give me my 8, which is right there. So I get 2 spots. Now let's do 0. F of x looks like it is 5, 6, 7, 8, 9. Plus 1, so I'm going to get 10. Okay, so it'll be 9 plus 1 gives me 10. So we see a nice pattern. 6, 8, 10 is going by 2s. So if we're to draw our straight line at this point, we'll get my, hey, it's going a little faster here. So we'll get my line, and it's going to go from here left. That's the pattern, right? But I'm not going to extend it to the right, because did I do okay with that line? Yeah, I think I did. I'm not going to extend it to the right because I'm anticipating the behavior is going to change when I get into the positive here, because g of x has that absolute value shape. So when x is equal to 1, here's the spot, g of x is equal to 2, and f of x is equal to 10, 11, 12. So here I get a 14. When x is equal to 2, I get a 1, 2, 3 for g of x, and I get a 10, 11, 12, 13, 14, 15, and so I get an 18. And when when x is equal to 3, I get a 1, 2, 3, 4 for g of x, and 20, 19, 18. I get an 18 here, so I get a 22. So you see how the behavior changed. Along here we're getting jumps of 2. Now we're suddenly getting jumps of 4. So if I plot some of these in here, 1 turns into 14, 11, 12, 13, 14. 2 goes to 18, 15, 16, 17, 18. And 3 goes to 22. I get there at 22. So I'll insert my line. And at this point now it gets steeper, doesn't it? So it's like a line that changes. And just to make sure we don't lose any half marks, so this does increase. I'm assuming that these lines increase. or continue on forever in that direction. But we'll talk about that, how the domain affects when you add or subtract. All right, so you know what, and again, let's skip the f minus g because I think you see the pattern. I think it's fairly straightforward. But let's get to some of the good stuff about, like, hey, when would you actually ever use this? So let's talk about a word problem here. Students at the school decide they're going to sell t-shirts as a fundraising activity. If their fixed costs are $250, that means just to get the printing presses going, it's going to cost $250, and the cost per t-shirt is $4, and they intend to sell shirts for $10 per shirt, then here's the things we need to do. Write an equation for cost, revenue, and profit. So we're going to have three equations that we're going to write here for part A. The first of all, I think we need to have some variable for the number of t-shirts, because all these functions are going to depend on the number of t-shirts. So what we're going to say is let n equal the number of t-shirts. We're going to introduce that variable. Now, we've already been told what letter to use for the cost function, the revenue, and the profit. So the cost function we don't have to introduce, but I'm going to make it very clear that it is a function using n, the number of t-shirts. Okay, so the cost is $250 plus $4 per t-shirt. So let's put this in. I could say 250 plus 4n, but I'm going to put the 4n plus 250 first, because then it's in that nice y equals mx plus b form. So if they make one t-shirt, it's going to cost $254, and so on. The revenue, that's how much money that they take in. They sell the t-shirts for $10 per shirt, so it's going to be 10n. Okay, now the profit, that's how much money that they make from this. The profit, it's a function of n, is going to be equal to, now it makes sense, it's going to be their revenue minus their cost, right? Or another way you can say this, r minus c of n, right? If I combine it together. How many t-shirts do they need to sell to make a profit? Well, you know what, why don't we do this last part here too? Why don't we just define this in terms of n? So if I put the numbers together, it's going to be a 10n minus 4n plus 250. So this is going to be equal to 6n plus 250. So in other words, their profit is 6n plus 250. That helps me answer part B here. How many t-shirts do they need to sell to make a profit? What does a profit mean? A profit means that not a negative profit, you know, to make a positive profit. So in other words, when is this value, plus 250, going to be greater than 0? When are they going to make that money? All right, that's what we're asking. So let's just solve 6n. Oh, did I make a mistake here? Oh, I think I did, and let's see if I can find my mistake. It is it's the old parentheses error, isn't it? 10n minus cn, so it's 4n plus 250. So this should have been a minus 250. And the reason why I caught it, I was thinking, oh, if I solve this, I'm going to get a negative value, and I don't want to sell negative t-shirts. So I thought there must be a problem here. So here's the problem. This should be a subtraction, right? It shouldn't be a plus. So we'll continue on here. 6n minus 250 is greater than 0. So 6n is equal to 250. So n is equal to 250 over 6. 41 and 2/3. Now let's just think about this answer. 41, can you actually have 41 and 2/3 t-shirts? No, you can't. So to make a profit, you're going to have to sell at least 42 t-shirts. Okay, which tells me a little bit about the domain and the range of the functions in this problem. So this last decision that I made about, hey, I can't have 41 and 2/3 t-shirts, can I? I gotta have 42 t-shirts. In other words, if I was to graph any of these functions, instead of x, well, we're using n, which is the number of t-shirts, right? And this is either, you know, cost or profit was our last one, p of n, right? So the domain is what can all the n values be. So for a domain, first of all, you can't have negative number of t-shirts. Could you make 0 t-shirts? Yeah, I don't know. Well, so I think you'd have to actually have a at least one T-shirt to be saying that you're selling T-shirts. Wouldn't you say so? I guess you could say I'm selling T-shirts. I didn't sell a single one. I don't know. So there is an argument to be made. But how about if I go has to be, oh, not less than, has to be greater than 0. We have to at least be selling T-shirts to be saying that we're selling T-shirts. And the other one is that n is an integer. So we're used to writing, I'm going to erase this in a second, we're used to writing this a lot, right? There's real numbers, so I'm trying to do it a little bit better there. But that's not what we want. We don't want to have real, because that would include numbers like 41 and 2/3. So really what we want to say is that n is an integer. Um, in province of Manitoba, they seem to be pretty happy if you write I for integers, or you can write where n has to be an integer. And a lot of other places in the world, they use this letter Z, and it actually comes from German. I think it's Zahlen, which means number, and apparently in set theory it means integer. So you can do this, and that'll give you a check mark. You can do this as a check mark, but I'm guessing most people in Manitoba just put n, where n has to be an integer. So how about range? The range, let's think of the profit here. The profit, well, if you actually made 0 T-shirts, then you would be losing $250, right? So the range, the smallest value you could be getting for profit, so we'll just do profit here. The profit has to be greater than negative 250. All right, and I guess in this case it is integers, but I think that's a coincidence because of the everything is in dollars. But I think we could just say the profit has to be greater than negative 250. Now, if you were to say, hey, you could be trying to sell T-shirts and end up only selling exactly 0 of them. Like if you were really good at arguing, you might be able to put those in there. But I'm of the opinion that perhaps it shouldn't be like that. So those, I would probably give you a check mark for both, because I just like you guys so much. Now let's take a look at the very last part here. The domain of combined functions, the domain of a combined function formed by the sum or difference of 2 functions is the domain, and the answer is common to the individual functions. And here I have a picture to show this, because here is f of x is the blue one, g of x is the red one, and h of x is the 2 added together. So this is the sum. So g of x, or f of x, pardon me, the domain of f of x would be less than 3. So x is less than 3. Now this is really fancy builder notation, set builder notation. So the domain of f of x, and we use the curly brackets, x such that x is less than 3, and x can be all real values. Really, we can get away with just putting this. Okay, and this other part is just saying that we're talking about x, and it is a set. Okay, so that's the other part. So I'm pretty happy if you just say x is less than 3, comma x is all real values. How about the domain of g? So the domain of g starts at negative 5 and goes larger than that. So here x is greater than negative 5. So now the domain of h of x, which is defined as the sum of f of x and g of x, has to be only the part that's common. So it would start here and would end there. So it would say this is negative 5, right? And this is 3. So we're going to say negative 5 is less than and equal to x, which is less than or equal to 3. And actually I should put, I think it does touch exactly negative 5 and 3, so I think I should put these in here as well, right? There, better. So this is the idea. This is what common means. It has to be true for both of them. So even though they're at, say at negative 6, f of x exists, but g of x does not exist at negative 6, so therefore you can't add, it's not a 0, it's like a g of x doesn't even exist there, right? So you can't say, oh, what would I add? Like if f of x here at negative 6 was equal to 3, right? If this is 3, but this isn't, you can't add 3 with no value at all. Okay, So I would like you to take some time to go back to the margins here and write out question, right? So how do you find the domain or what's the domain of a sum or a difference? And you could this is the answer to that question. So write in some questions here, and you can summarize your learning there. For homework, and you will be doing this in class, and I'll be getting you a copy, and we're going to be getting a nice new textbook. We have questions to work on, and some of them are for graphing, and you can do that using software. So thank you very much, and I'm going to see if I can stop the recording here.